Thank you. Questions so far? So the exam is a week from Friday, which is the, sorry, I'm going to just open it. If you go under on Blackboard exams and finals, it has the dates. So the in-class portion of the exam is April 2nd. Sorry. Is April 8th. Exam 2 is April 8th over chapter 6 through 10. We cover chapter 10 this week. We'll review next week. We'll review Monday and Wednesday. Exam in class on Friday. There's also a take-home portion, and it will be due that Sunday, the 10th, 11:59 p.m. Any questions? So there's this exam, which is next week, and then the final. Your in-class part of the final is Friday, May 6th at 8 a.m. It is not our regularly scheduled time, so make sure you have off. And the take-home portion will be due the Wednesday before, because I have to have grades in by Monday at 9 a.m. So the final is, the take-home portion is due on the 4th, so I can get it graded. Any questions? 5 more weeks. So we have the outline videos that you can watch on house payment. I did the steps also if you're having trouble, but it seemed like everyone was able to plug in pretty good when we did the examples 2 weeks ago. Effective rate, credit card, and savings account. Homework and group assignment and attendance. Chapter 10 deals with credit cards, effective rate, savings account. Got it. So we're going to do an example. Credit cards. Jim charges $125.24, and when the statement comes in January, it shows a minimum due of $20. If he decides to pay $20 a month with a 1.65% periodic rate until July, and then he pays it off in July, what will he owe for the last statement? So we know his balance when it comes is $125.24. If you pay that whole thing off, you don't pay any interest. So on a credit card, the first month, the interest is 0. And that's why in the statement it shows for January, no balance. It's a little bit bigger. Now, when you have a periodic rate, 1.65%, The annual rate, they just multiply it by 12. It's an estimate. The annual rate is usually what you use, but if you're finding it per month, it's a periodic rate. So if it says periodic rate, to get the annual rate, you just multiply by 12. If it's periodic monthly, and it did say monthly. Yeah. A month with a periodic rate. So to get your annual percentage rate, you multiply by 12. If you have credit cards, if you look at your statement at the bottom, it will tell you your annual rate and your periodic rate. Periodic means however many times they compound it in a year. Most are monthly. Any questions so far? So we get this credit card statement and the minimum payment is only $20. So he's going to pay $20. That means his current balance is $105.24. Now, when you're talking about the interest that you owe, it's only on what you left on the balance. So the interest rate in February would be on the $105, not the $125. Remember, you have to put it as a decimal point. Put the 0 first. 0.0165. Equals. And the biggest mistake, be careful rounding. Hopefully I multiplied these all right this morning. Are we getting $1.74? Yeah, any questions so far? So in February, his statement comes and it'll show that he has a previous balance, $105.24 plus $1.74 in interest. So his balance is $105.24 plus the $1.74, but then he's going to make another monthly payment of $20. So for March, to find March's balance, you take February's balance plus the interest minus any payment. So I took the balance from the month before plus the interest, because that's, if you wanted to pay it off, you'd have to pay the balance and the interest. And then you wouldn't be charged any more interest. But instead, he's making another $20 payment, so we subtract the 20, and he has a current balance now of $86.98. That's what he left on the credit card for that month. So that's what he has to pay interest on. Any questions? Does being paid periodic? So if you were given an annual rate and you're doing it monthly, you'd need to divide by 12. But most credit cards will show both. It's a payment, this could go up to 27% one payment. So for April, his balance then, when the statement comes, is 8698 plus the interest. So if he was going to pay it off and not have any interest in April, he'd have to pay the 8698 plus the interest. Instead, though, he's going to make another $20 payment. So he owes $68.42, and that's what's left on the card that month, so he has to pay interest on it. And this is assuming that he hasn't made any more purchases. Any questions so far? Okay, go ahead and do the May. $49.55 here. Be the $16.42 plus the interest for that month, and then he made the $20 payment, so minus the 20. Is that what everyone's getting? I'm getting 82 cents, 0.82. Any questions on May? Okay, go ahead and do April. I mean, I'm going backwards. June. You're getting for June $30.37 for the balance, and then 50 cents for interest. So then for the last one is at 1787 for the balance, and then he has to pay interest on that. $0.29. For July. 1787. I did it this morning, it could be wrong. Okay, so we had 3037. Oh yeah, how did I get, I must have been 3737. 3037. Oh, let's move this before someone says something wrong. 3037 plus the 50 cents minus $20. Oh, 1037. 1087. Which remains my interest. 18 cents. Any questions on the table? I wrote a formula here for new balance. It's the balance plus the interest minus the payment. So the last payment, if he wants to pay off the credit card, would be what? Mm-hmm. Because we would take the 1087 plus the interest for that month, which is 18 cents, and we'll get 1105. Any questions on that? How many months did it take to pay it off?
Last payment due at the end of July, or is July the last month?
I would go by how many payments he made. Yeah. I know, I was doing that this morning, I'm like, wait a minute, do we start with January, do we include? But it would be, I went by payments, so it'd be 7. Because he made a payment each month, and if he made 7 payments, then it took 7 months. Any questions on that? Of course, my interest is going. How much interest did he pay? Does everyone agree with that? 581. Yep. Just, yep. So one way of finding the interest is just to add all the interest up. Probably the easiest. You could also take all of his payments, 7 of them, and then subtract the balance. So one way, you add the interest and you should get 581. Or he made 7 payments of $20. So that would be $140 minus what he owed. And that should give us the same thing. That didn't come out the same. Oh, that's right. The last payment wasn't 20. So it was 120 for the 6 payments, plus the last payment was 1105. There we go. So that's another way of doing it. Take all of the payments that he made, subtract what he had owed to start with, and it'll get the interest that you paid. But when we have the interest separated right here, it's a lot easier to just add it twice to make sure you didn't hit a button wrong. Any questions on that? Okay. Mortgage payment. We talked a little bit about this formula because I had you plugging into it. P is for payment. Can you see it all right? Some of those values are pretty small. R is the annual percentage rate, because notice this is monthly, so they're dividing it by 12 to make it periodic. So R is an annual percentage rate written as a decimal. Y is the number of years. Most home loans are either 30 or 15. I'm sure you can find other ones, but most are 30 and 15. So if we are going to buy a home and put, like, the whole loan is going to be the 200,000 at 3.7% and APR's annual percentage rate for 30 years. So right here. Then we want to plug into this formula. E is the principal, the amount you're taking the loan on. And if we're doing it on the whole amount, then it's 200,000. Then we multiply by our rate as a decimal, 0.037 divided by 12. And then we want to divide by, now your denominator, depending how you're entering it in your calculator, this whole bottom should be in a parenthesis. One minus, parenthesis, 1 plus, rate again, 0.037 divided by 12. Caret, negative 12 times 30. No. This exponent, unless your calculator stays up there, if it just puts the character and then the number right next to it, you either need to multiply this and get the negative 360 or put it in parentheses. But when you plug it in, you're getting $920.57. Yes, no, maybe. I'll double check too. But They'll be getting $920.57. And if you, depending on your calculator, if you type it in exactly like this, it should work. You're doing it on your phone. Here, try it on a calculator. Sometimes the phone is hard, it doesn't always keep everything there. Anyone need a calculator? If you do not have your calculator with you, please, whatever calculator you're using for the text, make sure you practice on it first. Because I can't tell you how to do it once the test starts. Is everyone else getting $920.57? Put your 200,000, parentheses, rate 0.037, divided by 12, close that parenthesis, divided by, and another parenthesis. Yeah, because I hold it on there, it has to be in one, and I put the one on the outside, okay. So then 1 minus parentheses, 1 plus 0.037 divided by 12, close 1 parenthesis. Then the caret, parentheses, -12 times 30, close 2 parentheses.
I got the same answer going.
You got what, an error? Yeah. What are you getting?
I'm getting 616 and 66 cents.
That's what I got for the top. Because I did them separate. Oh, instead of times, you hit a caret here.
Oh, it's a time.
Yeah.
Thank you.
You want to be careful. This one, this is a multiplication. I should have used an X. Yeah, because it's -12 times the number of years. So we need a front. No, you want to have this in there. Negative. Oh, there we go. That's a -5. So I gave you an error. Close 2 parentheses. So, I know, when you have, like, this is a minus sign, because we're subtracting this quantity, but this is a negative 12. So when you're using a negative, your calculator doesn't want a minus sign there. You have to use, and it'll be at the bottom, it'll have a negative.
Oh, talk about the calculator, I can't see.
Oh, answer, A and S would be answer.
Okay, so that's the negative.
No, is it right there? Or is it right? Oh, yeah, it does have the answer above it, yeah.
Okay, so that's the one I would use.
Mm-hmm. The A and S, if you had a value and you wanted to use it again, you can hit your second and that button and it'll put the answer there. Add to it.
Okay.
So like if you did do, the top of the 200,000 times this first, then you can hit second and answer and it will use that value and divide.
Okay. Trying to subtract, but that negative.
Yeah, you gotta
be
be.
a negative, okay.
Most of the time, if you have some type of synthetic syntax error, it will be that. Or you're dividing by 0. So everyone has 92057. Did I put another one in here, or are we gonna make one? No, let's try another one though. So let's say that we're taking a home loan for 150,000 at 2.7% APR for 30 years. So find the payment. I'm getting $608.40.
Is the formula given to us on the test, or do we have?
Yeah, I'll give you the formula. It's hard enough plugging it in. I don't want it. This way I know you know how to plug it in. Are we getting $608.40? Okay. Now, how do we find out how much we contributed for the whole 30 years? How much we paid? You know we're paying $608.40 a month. So how much could we find? How could we find out how much we paid in the 30 years? Yeah, we could do that. So what we would do is the 608. Oh, not 6,000. 608 multiply it times 12 because it's 12 months, and then 30 years. So when you're finding the total contributions, it's how much you pay per month times 12 because it's monthly times the number of years. Your payment times 12 times the number of years. How much do we pay? A lot.
219,000.
So we're paying $219, $219,031.20. How much do we pay in interest? So we subtract the 150,000?
200.
Yeah. Oh, that's right. That was the second house. I mean, the first house. We're doing the second one. So for this house, the second one, the 219,000, that was from the $150,000 home. So to find the amount of interest, you take what you paid and subtract your loan. Yep. If you make one double payment a year, you can cut 10 years off of your loan, which then drops that interest a lot. Well, I bought my house for my grandma, so it's interest free. But what I used to do at my other house is, when my taxes came, I made a double payment. It'll drop 10, it can drop 10 years off of your loan, so you can pay it off 10 years faster. Which a lot of that is interest, so. Any questions on it? Okay, well then, that house man's pretty big, maybe we should save for a down payment. When you have a savings account, the interest is made monthly. So when you open an account for $100, at the end of that month, you've already made interest. Unlike this credit card, the first month you don't pay any interest. But a savings account, as soon as you put it in, you make interest that first month. So if you open an account for $100, at the end of the first period, you will have already made interest. And in this case, it was a monthly rate of 6%. So your interest would be 100 times. So $6. So it's a little bit different than the credit card. you make interest that month because they're using your money. Now this one says you're depositing $100 a month into an account that pays 6% a month. So for our next balance, then we have the $100 that was in there, plus the 6% rate and a $100 deposit. We have $206 that we're going to make interest on. So when this statement came, we had $106, and you put another deposit because it says deposit 100 a month. So at the beginning of that period, there's $206 that you're making interest on. So it's a little bit different than the credit card. Everyone sees where I got the 206 and the 1236. Go ahead and find the next year. Probably not both. On the in-class portion, there will either be a credit card or a savings one, and then the other one be on the table. So for the balance on the third one, are you getting $318.36, which gives us $19.10 interest. Okay, go ahead and find the last three. Hopefully do them all right. everyone getting these values? Last one, $697.53, $41.85 interest. Okay. So old balance plus interest plus if there's a deposit, monthly deposit. In half a year, how much money is in the account? So how much is in the account? Mm-hmm. 749.38. So at the end of 6 months, there's $739.38. How much did the person contribute? 600, yeah. Because they put $100 each time. So 100 here, 1, 2, 3, 4, 5, 6, $600. $100 a month for 6 months. How much interest was made?
$39.55.
Now what you could do is subtract these two because you know the total in there and the 600, or you add up your interest. You could double check yourself by doing both and make sure they match. But you could just add down the interest, or 739.38 minus 600 is 139.38. So in 6 months, you made $137 in interest. Oh, wait, I subtracted from the wrong one. 139. I think I was looking over here. And it's easy to do, so be careful. The biggest mistakes I see are rounding here. Those are the most common mistakes, so double check your rounding.
You want it rounded for each one? Because I was just keeping the answer in my calculator, so I was like 2 cents off or something. Or do you want it rounded to each and then restart?
I would round for each. Because each one is a separate statement, so it's the end of the statement. Some statements do keep that interest rate to as many decimal places. I don't know how many they go, but because they don't want to give you more than you should have. But any questions on it? Now, there's also what's called an effective rate. Like maybe you make 6% compounded monthly. An effective rate tells you, and what it's doing is it's including all the interest compounding in there each month. It will tell you approximately what you would make in a year, the percentage. So effective rate, if it's compounded, like this one's monthly, it will tell you 6% compounded monthly, how much you would make in a year. And it'll be a little bit larger than 6%. Because it's keeping track of the interest that you're making. Same thing here, if it's compounded daily, when you find the effective rate, it tells you how much that is in a year. To use it, we use this formula. Now this is when it's compounded amount, compounded monthly, daily, yearly. Compounded continuously will be a separate formula that we'll look at in a minute. So R is a periodic rate. It's not an annual rate. So if we have 6% compounded monthly, then we'd have 1 plus our rate is a decimal, 0.06, divided by the C is the number of times it's compounded in a year. So monthly, C would be what? Now the -1 is not in the exponent. Let's, did I put on here? Let's round let's round 3 decimal places. So round the percent 3 decimal places. Yeah. Mm-hmm. Okay, what if I plug in wrong? 6%, 0.06. Oh, I keep hitting. There we go. Okay, you should be getting 0.0616778,119. Now, if you're rounding 3 decimal places, make it a percent first, because if you only go 3 decimal places and then you make it a percent, your percent isn't 3 decimal places. Remember, this is the rate. You need to multiply by 100 or move it over first to get your percent. So we're actually rounding here. So we're going to move over 2, so 6.16, 3 decimal places, 8. So to make it a percent, we're going to move over 2 decimal places. So we have 6.167781, not 2 ones. So that's our percent. If we're going to do the percent 3 decimal places, then we're going to here. This 7 after it will round this 7 to an 8. Now I went 3 decimal places because these are going to be close. It's called the effective rate. Trying to get that to go. What it tells you is if you have 6% compounded monthly, then that's 6.168% in a year. So when you're opening up a savings account and putting so much money into it, they'll tell you, or a CD is one where you don't touch it, it just stays there. That 6% compounded monthly is like making 6.168 in a year. So it's adding on, you know how you make interest off of the interest? That little bit of decimal is adding to that interest that you're making off of the interest. So then the more times it's compounded, the larger this will get. So compounded daily will be a little higher. And you'll see that a lot in a lot of different loans. Is everyone getting the 0.0616778? So then remember, make it a percent first and then round. Okay, so daily would be how many times in a year? So 1 plus 0.06 divided by 365. Are you getting 6.183? A little bit larger than the last one because it's compounded daily instead of monthly. So 6% compounded daily is almost 6.2% in a year. I don't know why I put, I would never give you, well, I might. So hourly, hourly. How many hours in a year? 365 days times 24 hours. $87.60. Okay, so there's 8,760 hours in a year because I took the number of the number of days in a year times the number of hours in a day. You're getting 6.184. So hourly, oh, not much, but a little bit more than. No, most banks are monthly, some are quarterly. Quarterly would be how many times in a year? So if something's quarterly, it's 4. My dad's credit union went quarterly. So some things are quarterly, most are monthly. Any questions on calculating it? So make it, multiply by 100 first to get the percent and then round.
Is that what a question will look like on the test? Will it just say 6% compounded daily?
I would probably use quarterly or monthly. And then I would probably say to explain what that means. So 6% compounded in a year would be approximately 6.168%. And I said that backwards. Let me write it out. is approximately 6 point. So if you had to explain it, 6% compounded monthly is approximately 6.168% per year. So if we found how much we make in a year, by a month, how much we would by the year, they'd be pretty close. Any questions on that? So yeah, I would ask you to explain what it means. Okay, effective rate or compounded continuously. When it's, you don't see very much of this unless it's something you owe. Sometimes they'll do something like this, but it's just continuously compounding. So the formula for that is e to the r minus 1. Remember, e is the function in your calculator right by the ln button. So if we were doing it for the 6%, it would be e to the 0.06 and the minus 1 is not in the exponent. And again, it will be close to what we have, but a little bit larger. So when you put your e in, most calculators, instead of putting it in the exponent, it automatically puts the caret in a parenthesis. Put your 0.06, close your parenthesis, and then subtract your 1. So when you hit the E button, it automatically, most calculators, it already put the caret in the parenthesis. Yeah. So then put your 0.06, close your parenthesis, and subtract 1. You should get 0.0618365,465. So hourly's higher. No. 36. No, it's a little bit higher, but rounding where we're rounding. 6.18 ends up the same. But looking at the decimal place, 616, we have a 5. And it says a 3. So it's a little bit faster.
How would you explain that one if it's continuous? Does it never end? Is that simply just money in a thing indefinitely?
Well, it would be, you still explain it the same way. So 6% compounded continuously is approximately 6.184% in a year, because we're finding it for a year. So that estimate is for a year.
Even continuously is just a year.
Effective rate is looking at 1 year. But during that year, it will be compounding continuously.
Understand what continuous basis? What?
Pretty much, it finds the 6% of what's there and adds it on, and then finds it again, and then again, and then again. It just continuously, but it's pretty close to hourly. I don't know of any accounts right now that are compounded continuously. I'll have to Google that, but if there were, make sure you have a savings account and not an account where you owe money. But it says it, I don't know, continuously should be, it finds it and then it finds it again and then finds again, just keeps doing it. Any questions on that? I wrote a few problems to try. These are things like I would put on a test or a group assignment. I think this was a group assignment one year, maybe even last year. Julie wants to buy a home that costs $250,000. She's going to put down $50,000 and take a loan on the rest. She's trying to decide whether she should take out a 30-year or a 50-year loan. She found a 30-year loan at 3.869% and a 15-year loan at 3.211%. Write a paragraph helping her decide what she should do. Include what the payments will be, the total paid, and how much interest. So we'll start with the 30-year loan. You want to go back and look at your payment formula. We're taking, how much is the loan for? Because she's going to make 50,000 down. And a lot of times, if you do a 30-year loan or a 15-year loan, your interest rate usually in the 15-year loan, you can get a better. Sometimes they're the same, but usually it's cheaper. Okay, so we're getting a loan. Our payment is $200,000. Now, if we do the 30-year loan first, our interest rate written as a decimal, 30-year loan is this one. The 15-year loan is this one. So we're doing the 30-year loan. $0.3,869 divided by 12. So our rate divided by 12 then divided by parenthesis 1 minus parenthesis 1 plus, then the rate again, 0.03869 divided by 12. Close that parenthesis, caret, negative okay, so this would be our formula. The 200,000, the rate divided by 12, that was what was on top. And then on the bottom, and I put a parenthesis around the bottom, 1 plus the rate divided by 12, and then the caret, and then this is in my exponent. I forget what year I made this, but this is what I found for our loans. It was a couple years ago. We're getting $939. $0.79. So $939.79 payments. So that's what our payments would be. They also want us to find the total that we're going to pay and how much interest we'll make. Total paid is called contributions. It's how much money you paid. It's your payments times 12 times the number of years. Oh. Type it. $366,000. Did I type it wrong? 93979. Oh, I times it by 13. Oh my gosh, too many threes. $338,324.40. That's better. Um, you want to find your interest paid. Well, if you paid $338,324.40 for the house, but you only took a loan on 200,000, then if you subtract them, that'll tell you how much interest you paid. Enough to buy another house. A little bit smaller, but still. Or the land next door. There's a house, well, it was a house around the corner from us, and the whole kitchen caught on fire. You could see the melting on the shingles and stuff. I don't know what happened on the inside, but they completely brought the whole house to the ground. So now they're selling the land, and I told my son, I said, you should go find out how much that is. You could buy that land, and then you could start building on it now. Any questions on that? Okay, let's find out the 15-year loan. Do we think it'll be higher payments? Could be. Will the interest be about the same? No. One, because the interest rate is lower, but also you're only paying it for 15 years instead of 30. Big difference. Okay, so 15. So go ahead and find the payments. It's still the 200,000, but then the interest rate changed. Also remember the -12 times y. Y is the number of years, so now it'll be a 15 instead of a 30 in the exponent. Getting $1,401.55. Everyone getting $1,401.55? This is one on a test. I would plug it in and then plug it in again and make sure it matches.